Okay, page 76 now. So maybe this one we can do in one class. I know the other ones are more difficult, so we'll see. We might have to do this over 2 classes. Okay, so these are, if you look, you can see these are all rational functions. Do you remember rational functions? So for example, the first one is constant over quadratic, linear over quadratic, linear over quadratic. So these are all rational functions. So let's just start here. So if you remember, with a rational function, you have something like power n on the top, and then power m on the bottom. So we call this proper if n is smaller than m. So for example, this one is proper this one is proper, this one is proper, because the power on the top is smaller than the power on the bottom. Okay. We're missing Marcelo, Albert, yes. Remo, yeah. Not John Way. No. Not Leon. And Malik, yes, okay. Is there an assignment today?
Yeah.
Business? EAP? What's the due time? Everything makes sense now. Okay. Right. So, what we're trying to do today, for example, is let's go back one step. Suppose we had to do something like this: 4 over x plus 1 plus 3 over x plus 2. On the bottom you would get x plus 1 times x plus 2, and on the top you would get 4 x plus 2 plus 3 x plus 1. So on the top that'd be 7x plus 11, and then on the bottom we have x squared plus 3x plus 2. So what we want to learn today is how can we start here and go backwards. These are called partial fractions. So this is how do we go back. Because for some problems in maths, having it written like this is much easier than having it like this. So we would like to learn a way to go backwards. Okay? I don't know, has anybody seen this before? No? No? Okay. So how do we do that? So I'll show you with an example first. Can I go down? Minus 12, 3x squared plus 8x plus 4. So your first step to going backwards is to factorize the denominator. So let's say that'd be 3x, that'd be x, 2 and 2. Yeah? And then what you do, after you factorize is you say, let this equal a over 3x plus 2 plus b over x plus 2. Now, if you want to be very clear about this, if I just go to the side for the moment, if I said something like this, here you can find x, so this is called an equation, as you know. But if I wrote something like this, that's not an equation. I can't find x here. It's just me saying some like rule. So this, if you want to make it clear there's a difference here, a lot of people put 3 lines here. So in this one here, you can't find x. You're just saying that these are the same thing. So here, if you want to be very clear, you're just saying that they're the same thing. Also, notice this. This is only true if x equals minus 1 over 3, right? But this is always true for all x. So for example, if I said x is 4, 4 plus 4 is the same thing as 8. So my point here is this should be true for all values of x. Okay, so what we'll do next is we'll multiply everything by 3x plus 2, 3x plus 2, 3x plus 2. So that will cancel, and that will cancel. And you can probably guess what we should multiply by next. X plus 2, x plus 2. Oh, Malik, why are you so late?
Sorry.
I missed the reason. What's the reason? To make it good.
I was not late.
Oh, that's bad. Come on. Here we can cancel x plus 2, and here we can cancel x plus 2 as well. So what you're left with is minus 12 should be the same as a, x plus 2, plus b, 3x plus 2. Okay, so there are 2 ways you can continue to find the a and the b. Yeah, continue. Tony? Continue? Yeah. There's 2 ways. I don't mind which way you use.
Let x equals minus 2.
That's one way. I'll do that way second. Okay, let me just make a bit more space. Right, so the first method here is you multiply it out. You get minus 12 should be the same as ax plus 2a plus 3bx plus 2b. So minus 12 should be the same as a plus 3b x plus 2a plus 2b. So here you get 0x plus minus 12 should be the same as a plus 3bx plus 2a plus 2b. So what I did was I made a linear on the left and a linear on the right. And if they're supposed to be the same linear, then it means that 0 must be the same as a plus 3b, and minus 12 must be the same as 2a plus 2b. So solving this isn't too difficult, because I can change this into 2a plus 6b equals 0, and here 2a plus 2b equals minus 12, and I'll put them together and I'll get 4b equals minus 12, so b equals minus 3, which means that a must equal 9.
4b equals 12.
4b equals 12, yeah?
Yeah, what is
Minus 12. 0 minus 12.
Oh, thank you. So it should be 3, which changes this just to minus. Great. So like I said, that's one way to find the a and the b. But not the only way. So the second way you do it is, you know as well, if this is supposed to be true for all x, this should be true for x equal minus 2. If it's supposed to be true for every value of x, it should be true for this value of x. So that means you get minus 12 equals 4b. No, again with the signs. Minus 12, minus 6 plus minus 4. Minus 4b, so that means b equals 3. So now you have minus 12 is the same thing as a x plus 2 plus 3, 3x plus 2. And again, if this is true for all x, it should be true for x equal to minus 2 over 3. Now you maybe you're wondering, how am I getting these numbers? Why am I using these numbers? Of all the numbers, why do I use these? And I hope you can see that I'm deliberately picking these numbers because I can make parts of it 0. So I'll get minus 12 should be the same thing as a, and this will be 4 over 3. So that means a will equal minus 9. The same answers as it should be. So if I go back up to my question, I now know that this thing here I had at the start, I have my a and b. It's the same as minus 9 over 3x plus 2 plus 3 over x plus 2. That's the answer. If you add these together, you do get what I had at the start. Okay. I don't really like this method because you're doing something I don't like. I wonder if anybody can see what that might be. So why I don't like this method is you're using a value of x that you're really not supposed to use, because here x does not equal minus 2 and x does not equal minus 2 over 3. The exact values I used. Now the reason it's not a problem here is too complicated to explain. But I don't really like this method because of that. But it's okay. You can do this in the exam, and in fact, I think they expect you to do it this way because it's a lot quicker than doing it this way. But both methods are fine for me and for the exam. Let's have a look at another one now, a little bit more difficult. So this example was just to give you the kind of method. So let's try minus 22x plus 62 all over 45x squared minus 19x minus 42. Okay. First job, factorizing. Okay. I feel like 9, 5, 7 and a 2. No, 7 and 6 and a 7. 6, 7 and a 6. And then which one will be the minus? This is plus 1 and this is the minus 1. Okie dokie. So now we know that this is equal to A over 9x plus 7 plus B over 5x minus 6. So again, I multiply everything by 9x plus 7, 9x plus 7, 9x plus 7, cancel, 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 5x minus 6, 5x minus 6, 5x minus 6, cancel, 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 cancel. So now I'm left with minus 22x plus 62 equals A 5x minus 6 plus B 9x plus 7. So I'll use the second method. We'll say let x equals 6 over 5. Minus 22 times 6 over 5 plus 62 equals B times 9 times 6 over 5 plus 7. So maybe somebody with a calculator can give me the B from that. Then the next one to do is let x equal minus 7 over 9. So then we get minus 22 times minus 7 over 9 plus 62 equals A times 5 times minus 7 over 9 minus 6. A equals. Did we get the B? It's 2. Okay. And the A? So the answer is minus 8 over 9x plus 7 plus 2 over 5x minus 6. Yep. Can I scroll down? Now the next example, so the first two examples have been without any major problem, but the next one now, things start to get a bit more difficult because of something with the quadratic. X squared minus 10x plus 25. So when you factorize, you get x minus 5, x minus 5. So then what do we do here? So we might think, oh, okay, no problem. I'll just do the same thing I did last time, which is wrong. So I'll put it in red. You might think, oh, I'll change this into a over x minus 5 plus b over x minus 5, which is the same thing as something like c over x minus 5. And no way can that be made into that. So it doesn't work this way. So, yeah?
XB?
No, not that one. Not that one.
You get to one on the square.
Yes. Yeah. So what happens when you have these problems? You start off the same. You say equals a over x minus 5. But the second one is not x minus 5 again. Instead it's x minus 5 squared. So when you have something which is repeated, you keep it the same. And you also use the linear part. Okay? So after this example, what I'm going to do is give you some kind of guidelines for how to decide. Yeah, go ahead, Leon, ask me. Don't be shy. Alright, that's okay.
Why x minus 5 squared?
Yeah, watch this now. Why x minus 5 squared? So, if I use this, I can change this into a x minus 5. You don't have to write this part down, okay? Over x minus 5 squared plus b over x minus 5 squared. So here you'll have x minus 5 squared, and on the top you'll have a linear. So it's the same form as the question. But if I didn't have the square, what would happen is I'd end up with a constant over a linear, which is totally different to this. So I need to put the square in to make it the same form as the question. But after this example, I'll give you some basic guidelines for this, okay? So we do the same thing as last time, so I'll just jump straight to the equation we care about. Minus 6x plus 22 equals a, and it'll be x minus 5 plus b. What did I multiply everything by here? I multiplied everything by x minus 5 squared. X minus 5 squared, x minus 5 squared. So now I have it as one line, which is nice. What do I make x equal to? 5. So that means you get 8 equals b. So now you have minus 6x plus 22 equals a, x minus 5 plus 8. Now what do you choose for x? Well, it doesn't really matter. You can choose anything. What will we choose for x?
0.
0, yeah. So now we get 22 equals minus 5a plus 8. So what's that? A equals minus 3. No. It's minus 8, thank you. It's minus 8.
Why minus 8?
On the left here, when you put in 5, this will become minus minus 8. And this will be 0. So B is minus 8 then. B is minus 8, minus 8. So that means we get 22 equals minus 5A minus 8. So that means A equals minus 6. So we're finished. We have our answer. And we put it in here. A is minus 6 and B is minus 8. Yeah? Okay. Let me just... Yeah, there's still more different types of problems, but before I go on, let's have a look at some kind of guidelines. Now, most books don't give guidelines, so I kind of just made these guidelines up. Maybe they could be better. I don't think so, because they always work for me, so that's good enough. So we'll call them Stephen's guidelines. Okay, so let's say we have... Well, I want to kind of keep it general, so let's say on the top it's power n, and on the bottom is power m. So my first rule or guideline is you should try to break it up into m fractions. So for example, if this is a quadratic, we should have 2 pieces here. If it's a cubic, we should have 3 pieces. That's the first kind of guideline. Second, when you look at the right, so the pieces on the right, if I have a power here, then what you have on the top should be 1 power less. So for example, if this was a linear, what should you have on the top? You should have a constant. And if down here was a quadratic, in your answer, what should be on the top here? A linear. So if you look at my last example, of course that's true. If this is a linear, this here is a constant. And if this here is a linear, this here is a quadratic, so what should this be? It should be a linear. And it kind of is, because it's like there's a 0x here. But we'll talk more about that in another example. The next thing now is the number of constants here and the number of constants here should be 1 less. So for example, if you had here 2x plus 3, how many constants are here? 2 constants. So on the top you should only have 1 constant. I'll give you, and another example would be, suppose you had something like 2x squared plus 3 plus 1 in your answer. How many constants here? 3. So on the top you should have 2 constants. But now here's an interesting one. If you had x minus 1 squared, how many constants here? 2. 2. So how many should be on the top? 1. But the second rule says the top should be linear. So you actually have a choice here on the top. You can call it just b, or you could call it bx. And in fact, both will work. So you can have b or bx on the top. These are both linear, and they both have one constant, and the bottom has 2. So I know it's seeming a bit complicated, but when we do some examples, it won't be as bad. And the last guideline is if in the question you have something which is repeated, like something like this with a square, you keep the linear and you also use the squared. And I think also if it was a cubed, you would continue the idea up to power 3. So we have some basic guidelines. Let's do an example now with a cubic in it. Or actually, let me go back to the last example for a moment. Can I go back up for a moment? So here, in this example, I said a over x minus 5 plus b over x minus 5. Let's have a look at that again. X minus 5, we said a. How many constants are here? There are 2 constants. 1 and minus 5. Here's the 1 and here's the minus 5. What type is this here? It is quadratic. So what should we have on the top? We should have a linear. How many constants should be in our linear? 1. Because here there were 2, so on the top there should be 1. So that gives us a choice. We can either go with bx, that's 1 linear, or we can go with b. In this example here, I went with this choice. But we could have gone with this choice. And you'll get a different answer for b and for a. So what I want you to do now is kind of a little practice, is I want you to do this question again, but this time I want you to use a bx on the top. And tell me what you get for a and b now. Yeah. Oh, and I'll tell you now that the b will be a fraction, will be an ugly number. Okay, so you should have this equation here to get the a and the b. Is that right? Yeah. So if I make x is 0, I'll get a is minus 22 over 5. And then next I'll say let, I don't know, it doesn't matter, let x equal 1. So then we'll get 16. Oops, stuck. I get 16 equals a, which is minus 22 over 5, times minus 4 plus b. So then the b will equal whatever that is. Can someone do that? 16 plus 88 over 5. It's going to be ugly. Oh, kind of nice. Minus 8? 5. So, if you look here, we can now say this is equal to, instead, a we said was minus 22 over 5, and then b we said was minus 8 over 5x. So I suppose if you want to, you don't have to, but if you want to, you could bring the 5s down into the bottom, but you don't need to do that. So what I want to do is I want to show you that these are actually the same, even though they look totally different. These two answers, they look very different, don't they? This answer we just got and the answer we got a minute ago, it's hard to believe that they're actually the same answer, exactly the same. So I want to show you that they are.
Why you didn't let x equals 5?
Oh yeah, I could have.
This is different answer.
Oh no, you should not. You should get the same answer. If I say let x equal 5, you get the same answer. If I say x equals 5, you get the same. Yeah. Okay. Yeah, I don't know why I did that. I'm tired. It's the same answer. Who cares? Okay. Oh, sorry. So let me just open up the program. So what I'm going to do now is I'm going to add this together and see if I get this. I should get it. And I'll do the same for the other answer as well. Yeah? Okay, so wait for it to open. I did click it, didn't I? Come on. There we go. Okay. So, can you just give me the first answer we got a few minutes ago? What was it? Minus 6 over x minus 5 plus minus 8 over x minus 5 squared. So let's add these together. I won't go through that because that's not interesting. So I know it looks a bit different, but on the top we get 22x minus 6x. Same. And on the bottom we get x minus 5 squared. It's the same. So this answer is correct. It will give us the question. Okay, what was my second one? Minus 22 over 5 over x over 5. And then the other one? Is this. Okay, so moment of truth. Do we get the same answer? And amazingly, we do. Which I think is kind of amazing. That these two answers, they look very different. But in fact, if you simplify them, you get the same answer, which is the question.
Which one is best for integration?
Which one is best for integration? In this case, I think the first one. Because these can easily be integrated by using a substitution. Let u equal x minus 5 and let u equal x minus 5. This one here is a little, no, actually both are equally the same. Okay, so like I said, these lessons are a little bit longer. I didn't get time to do any cubics, I've only done quadratics, so next time we'll have a look at some cubics. But if you want to know which ones you can try, you should be able to do the quadratic ones. So I actually did, you see there ABC, and you notice that there's more quadratics on the right, KLM. So these are the ones you should be able to do, KLM. Okay. Next time we'll have a look at the cubics. Okay. So unfortunately you can see some people are missing, which means they'll be joining the middle of a difficult lesson. So this is the advantage of going to all your classes. Yeah? Yeah. The class at 1 o'clock is optional. I think what I'll do, I'll see if people have some questions from the book that they want done.
September exam?
No, not yet. September exam. If I do that, I'll do that later. I will, if there's time, I will do some past exam questions though, because now that we've covered more, I could do like some calculus past exam questions. So it's just going to be like a tutorial, whatever questions people have. There's no new material. I think it's A401, I think, at 1 o'clock. Is that right? Yeah. Okay. Right, we'll leave it there. It's 1 hour today, isn't it? Yeah.